Now we move into the realm of electromagnetism, and we start with just a magnet, just a regular bar magnet. We have a compass at A, and we know its direction, and the first question is asking us to identify which directions the other compasses will be pointing in. So using the information given by A, we know that the field on the right side is pointing outward this way. And we know that the shape of a bar magnet, or the shape of the magnetic field for a bar magnet, has like this butterfly pattern, like this. So if my field at A is going outward towards the right, that means that at C, which is like my opposite end, it's going to be going into the magnetic or into the magnet. So that means that my arrow is going to point also towards the right. And if we follow the shape, if we go out of the right and then around and into the left, that means that at this point out here, and likewise at the top at D, we are going towards the left in order to follow this circular pattern that the magnetic field has. So that's a leftward arrow at D and at B, and then a rightward arrow pointing into the magnet at C. And that's the very same information we're going to use to label north and south. So if C is pointing into the magnet while A was pointing out of the magnet, that means that this is my north pole, because magnetic field always comes out of the north and into the south. Mark-wise, this arrow is worth 1 mark, and these two arrows, they need to be doing the same thing, and the correct thing, which is pointing towards the left, that's the 2nd mark. And then north and south is just 1 mark. Then we are asked for one method to demagnetize the bar magnet. So from domain theory, we know that magnetization happens when all of your domains are aligned. So that means that all of them are pointing in the same direction, and so each of them has a little north and a little south. And because they're all pointing in the same direction, I end up with a net north and a net south, and that's what creates a magnet, right? Like with a defined north and a defined south. So if we're trying to demagnetize, that means that we want all of these to fall out of order. That way it's all random again, and I don't have these main north and south regions. So there's 3 ways to get these domains back into their natural chaos. The first is we're going to heat it up, but not just normal heat. We need to make sure that there's enough kinetic energy for them to deorganize themselves. So we need to heat it up to a high temperature. So if this is the method you chose, you get 1 mark for saying heating it up, and then the other mark for identifying that it has to be a high enough temperature. Another method is we're going to hit the magnet with a hammer. Can't spell, with a hammer. And we're going to do this repeatedly to make sure the domains are properly shaken out of place. So that's another set of 2 marks, one for identifying the hitting with the hammer, and the other that you have to do it multiple times to make sure that it is well shaken. Or likewise, instead of repeatedly, you could say we hit it into like an east-west direction, meaning you're hitting it like this way to, again, make sure that things are out of their alignment. And the last one is we're going to use magnetism to our advantage in this case. So we're going to place it into a coil or a solenoid that has an AC current in it, and then we're going to remove it. So by putting it into an AC current solenoid, we are exposing it to a magnetic field that's constantly changing, And then once you remove it, you are going to essentially change the magnetic field so much that the orientation is not going to be favored anymore. So those are the 3 possible methods that you could have chosen. That's where each of the 2 marks comes from, given each of the 3 methods. So you could do either of them and still get 2 marks. Just make sure that your 2 points belong to the same method. And then we have an electromagnet now. So we have a current carrying wire that is going in like a in and out of the page kind of situation. It's hard to, I guess, inward, outward. Can't really draw it because it's 2-dimensional, but the fact that there is an X means that my current is going like into the page. Again, hard to draw. So what we're gonna do is we're gonna take our thumb, we're gonna put it into the page. You can't really see me doing it because you can only see my screen, but essentially my thumb is poking at the screen while my fingers curl around in a clockwise direction. So we're going to draw a field nice and round. Again, use a pencil because our circles aren't always perfect the first time around. Thankfully, I have technology to help me out. You don't, so use a pencil. So here's my first, I don't know how to get rid of this. Go away. All right, whatever. Circle. There we go. And it needs to go clockwise. And you need at least 3 of these circles. Anytime you draw a field line, you want to draw 3 if it's a circle, 4 if it's straight lines. And again, going clockwise, and you'll notice that every time my circles are getting bigger because my field gets weaker as I move further away from my wire. And all of them are clockwise. Then, question part 2. The direction of the current is reversed. So now instead of having an X in my wire, I have a little dot, which means that my thumb is pointing towards me and not towards the inside of my paper. And you'll notice that the direction of your fingers has now changed. So your fingers now curl counterclockwise, which makes sense because the magnitude of the current hasn't changed, only the direction, which means only the direction of my magnetic field will change. So that's where my 1 mark comes from. What is the effect of reversing the current? The magnetic field is reversed or changes direction. And when you say change direction, you want to say opposite direction specifically. You want to specify the direction.